Hey guys, today we are looking at 4.3, which is our last section that we're going to cover in Chapter 4, and the last section that we'll cover in the first semester. This will be the last topic that will be on our final exam. Woot woot. So, today we're talking about 4.3, which is all about equations of parallel and perpendicular lines. Parallel and perpendicular lines. So just jumping right in here to box 1, just a little definition. Parallel lines, we know those parallel lines, if you think of like railroad tracks, there are two lines that are never going to intersect with each other. And we know in order for that to be the case, in order for them to never intersect with each other, they have to have the exact same slope. So what we'll do if we're trying to determine if two equations or two lines are parallel, we would look at their slope, identify what their slopes are, and then any slopes that are the same, we would say that those two lines are parallel to each other. So just as a quick little refresher, remember our slope formula, y2 minus y1 over x2 minus x1. If you're not comfortable with that equation, today we're going to just work right through that. You're going to do a lot of that, a lot of utilizing that equation. Because what we're going to do here, we're given the format of our question, we're determining if the lines given are parallel. So we're given three different lines, line A, line B, and line C, and I'm given ordered pairs, 2 points that are on my line for each of those three lines. So what I'm going to do, I'm just going to go through and find the slope of each of those three different lines. Any ones that have the same slope are parallel to each other. So for line A, if I do y minus y, so again, y value minus y value up top, x value minus x value in the bottom, 3 minus 2 is a positive 1, negative 4 minus 1 is a negative 5, so negative 1/5 is the slope for line A. For line B, we have y minus y up top over x minus x in the bottom. So minusing a negative, subtracting a negative makes it a positive 1 over negative 4. So far we know A and B are not parallel to each other because they have different slopes. Line C, I'm going to do the same thing. Line C, y minus y up top over x minus x in the bottom. Again, subtracting a negative makes it positive 1 over negative 5. So we can see here from that information, we're able to tell that because line A and line C both have a slope of negative 1/5, we can say that lines A and C are parallel. So I can answer it that way. Our symbol for saying that two things are parallel to each other, if you notice kind of here in the middle of the word parallel, we have that double L. It looks like a pair of parallel lines. That is our symbol for saying the two things are parallel to each other. Kind of like it looks like an absolute value with nothing in between, just those two vertical bars. That says that A is parallel to C. Okay. Another thing that I can be asked to do with this information involving parallel lines, I could be asked to write the equation of a line that is parallel, that passes through a particular point, but is parallel to an equation that they give us. So a little bit unique in the process that I'm doing here, but really what they're saying is my line that I'm trying to write the equation for goes through that point, 5 comma negative 4, and since it's parallel to y equals 2x plus 3, I'm going to use this slope from that equation because we know if they're parallel, they have the same slope. So if I'm writing the equation of the line using that information, I'm going to say, all right, well, I know I want my slope to be positive 2, and the x value 5, y value of negative 4 from that information. I have those three pieces of information. If I'm trying to write the equation of my line, just like we did in 4.2, I can utilize slope-intercept form here, y equals mx plus b, and I'm just going to start substituting stuff in here. My m is 2, my x is 5, my y is negative 4. So plug those three things in there and solve for b. So negative 4 equals 2 times 5 plus b. That gives us negative 4 equals 10 plus b. So when I subtract 10 on both sides, we get a b value of negative 14. So that tells me that my slope is positive 2 and my b value is negative 14. So the equation is a line that passes through 5, negative 4, but is parallel to y equals 2x plus 3. The equation of that line should be y equals 2x minus 14. So again, here that makes sense because these two lines have the same slope. They're both 2x, but they have a different y-intercept, meaning they don't cross each other. One is up there at positive 3, our other one is down there at negative 14 for where it crosses. Okay, so that's parallel lines. Our other idea that we're talking about here for boxes 3 and 4 are perpendicular lines. Now, perpendicular lines are lines that cross at a right angle. So if I was going to sketch a little picture of perpendicular lines, we could do something like, we got this here, and then, oh, I need to make another one here. Let's just say that looks about 90. So we've got these two lines intersect each other at exactly 90 degrees. So they intersect at right angles. And the thing that we know about them in terms of their slopes, the way that works out when they make a right angle is that the slopes are negative or opposite reciprocals of each other, meaning they're the same numbers, but one's flipped over and is the opposite sign. So if my slope was positive 2, the opposite reciprocal, the negative reciprocal from positive 2 would be a negative 1/2. I'm just taking that fraction and flipping it over. The process that I'm doing for identifying when two lines are perpendicular to each other is the same as what I did up in box 1. I'm going to start by just figuring out what my slope is in the problems before I can identify whether they're perpendicular or parallel to each other. So here it's a little bit different. If I was giving it to you using 2 points, so I'd do the same process as we did up in box number 1. But here we're given the equations and we have to find what our slope is. So here for that, we're just going to rearrange it into slope-intercept form. Now, line A is already done for us. It's y equals mx plus b already, so that positive 4 attached to my x, that's my slope. That's my m value. I have to rearrange line B and line C into slope-intercept form in order to figure out what the slope is. So I have to start by subtracting x on both sides for y equals negative x plus 3. When I divide by 4 all the way through, I end up with y equals negative 1/4 x plus 3/4. So that tells me my slope for B is negative 1/4. And I'll do the same thing for line C. Line C, negative 8y minus 2x equals 16. So I'm going to start by adding 2x on both sides. Negative 8y equals 2x plus 16. I'm going to divide by negative 8. Sorry if I'm going through this quickly. You guys can slow me down or back me up and let me go a little bit slower for your own pace. When I divide through by negative 8 there, I get 2 over 8 reduces to a negative 1/4 x, and that ends up being minus 2. So my slope for line C also ended up being negative 1/4. Now, we have, in this case, a couple of different relationships here. Now, because my slope for line A is positive 4, we know that if I wanted to put it as a fraction, that would be positive 4 over 1. Put a little or, positive 4 over 1. So if I'm looking for relationships, lines that have the opposite reciprocal, the negative reciprocal, that means if I flip my fraction over and then change the sign, that's what a negative reciprocal is. So we see here that line A, with positive 4 over 1, is perpendicular to both line B and line C. And in this case, it doesn't ask us to, but we can. We can also conclude that here, since these two have the same slope, lines B and C are parallel to each other. So we'll go ahead and make those conclusions. Line B is parallel to line C because they have the same slope. And then we can say line A is perpendicular to lines B and C. And the way that we'd write this, our symbol for perpendicular is kind of an upside down capital T. We could say A is perpendicular to B. And we also know that A is perpendicular to C. So we make those three conclusions. We know B and C are parallel to each other. A is perpendicular to both B and C. All right, last section here. For box number 4, equations of perpendicular and parallel, of perpendicular lines. Same idea as what we did up in box 2, but not with perpendicular. So they're telling us, or asking us, to write the equation of a line that passes through this point, -3, 1. But instead of being parallel to our equation, we want to be perpendicular to our equation given, with y equals 1/2 x plus 3. So now, when I extract that information that I want, my line that I'm given had a slope of positive 1/2. So I have to do the negative reciprocal, the opposite reciprocal, to find the line that is perpendicular to it. The slope is perpendicular. So here, the opposite reciprocal, the negative reciprocal of positive 1 over 2 would be negative 2 over 1, or negative 2. I still have my x and y value here. X was -3, y is positive 1. And then I'm jumping into slope-intercept form to try and write the equation of my line using that information. Y equals mx plus b. So if I plug in positive 1 equals -2 times -3 plus b. So my y was positive 1, my m is -2, my x is -3, and my b is what I'm trying to solve for. So 1 equals 6 plus b. So when I subtract 6 on both sides, I get -5 for my b value. Once I know that, I have my slope, I have my b, I can write my equation. Y equals -2x minus 5. -2x minus 5. And that is my equation that goes through the point -3, 1 and is perpendicular to y equals 1/2 x plus 3. And that is it. That does it for 4.3. That does it for what we will cover in Chapter 4. That does it for what we will cover in Semester 1. Quarter 2, Semester 1, all of that stuff. Homework is up there on the board, or on the screen, I guess. It's page 191, 4 through 24 evens. If you have any questions, concerns, thoughts, ideas, hopes, or dreams, as always, make sure you guys are reaching out and letting us know. If you've gotten this far in the video and you're watching it before when you're supposed to be watching it, so I gave this to you Wednesday going into Thanksgiving break, so you're supposed to have watched it before Monday. On Monday morning, when I ask if anyone has a question based on the notes, you're going to have your microphone turned on before I do that, and you're going to have your camera on. I want you to gobble like a turkey. If you do that, when I ask, does anyone have any questions from the notes for 4.3? If you gobble like a turkey, I will give you an extra credit point on the final. Now, if you're watching this after the fact, if Monday morning has already passed and you're just watching this, sorry, you missed out. You should have watched it during the time when you're supposed to be watching it, before the class starts, which is the whole idea of me posting them early. So, if you've made it this far, and you remember this on Monday morning, when I ask, does anyone have any questions on the 4.3 notes? And you go, I will give you an extra credit point in the final. Have a good one.